Hi, welcome to this lecture on mathematical methods for biologists. We have been learning how to compute derivatives. We learned how to compute derivatives or finding slopes of simple functions like x, y is equal to x and y is equal to x square and even y is equal to x cube. And we found that finding delta y by delta x for small value of delta x is the local slope, right? It is the local slope. Locally, we can find the slope and that is the derivative. And while we do this, whenever we do in this, we should always think, why are we doing this? Why are we learning to find derivative? Why are we learning this calculus differentiation? So why this is something that we will think about it today. So while today's topic is calculating derivatives and we will discuss rules for computing derivatives. So today's topic would be calculating derivatives and rules for computing derivatives. And we will worry about, first we will quickly a little bit think about why are we learning to compute derivatives, why are we bothered about it at all, right? This is always good to understand, good to think about it so that we get some sense of what we are doing, and as opposed to blindly following something and learning something because it's there in the textbook or because it's there because somebody teaches you want to learn this. Always good to ask why are we learning this. So it turns out that we do experiments as biologists, and from experiments we learn that we will get data and we can plot the data as a graph. So everything that we see around us in nature, we plot as graphs. That's quantitative way of describing what is going on around us. That is something that we discussed in the earlier lectures. Now, when we have some data, it's not enough to know how the data looks like, how does the graph looks like. It is also important to know how does that quantity that we measured changes. So the change in that quantity, how fast they changes, how slow it changes, how within this many distance would it change? Would it change as a function of time, as a function of space? How would it change? This is important to understand. So let me say this once more. It is important to understand not how the data looks like. It is also important to understand how the data changes, how fast it would change, or how slow it would change, or in space, would it change quickly in space? That is, as you go along a certain distance, or as you go from one part of the cell to the other part, would your protein concentration change? Right? For example, this is something, the change in concentration, or how fast the number of cells change. So the change is something that we always want to know to understand the nature around us or to understand any phenomenon. So calculating derivatives or computing derivatives is the way to compute how things change. So therefore, why are we learning? To better understand any graph or data that we get from experiments, we also need to understand how it changes or how it varies, both in time, like how fast it would vary, and also in space. So that is one reason why we are learning derivatives. So in a given data set, that is, if we have a graph, we not only have information about the function, but also have information about its derivatives. And derivatives will have some physical meaning. So the information hidden in the data that we experimentally measure will have not only just the data, how it looks like, but also something hidden in it which is in terms of its derivatives. So therefore, it is important to understand how things change. That's the reason why we learn derivatives. Okay, so that is, it's always important to think why we are learning it. Now let us come back to what we learned. So yesterday we learned we have a function y is equal to x square. We had y is equal to x cube. And when we calculate the derivatives of this, dy by dx, we calculated and we got 2x. And here we calculated dy by dx and we got 3x square. So now in the general question is, if we have y is equal to x power n, what would be the dy by dx? Right? If we have, instead of x power 2, x power 3, if it is x power n, what would be the dy by dx? So that is what one of the rules of derivatives that you should learn. If we have y is equal to x power n, the dy by dx, the derivative, is n x power n minus 1. So n is any number. So if n is 2 here, it is 2x power 2 minus 1, which is 2x. If n is 3x power 3 minus 1, which is 2, which is 3x square. So in general, if we have n x power n minus 1, so if we have y is equal to x power n, dy by dx is n x power n minus 1. We can put any value of n. If we let us put n is equal to 7, dy is y is x power 7, and dy by dx, corresponding dy by dx, is 7x power 7 minus 1, 6. So this is applicable for any n, and it is also applicable for fractions. For example, if, first of all, before that, let us take n is equal to 0, something that you would want to take, you would want to learn, right? If n is 0, what happens? So if n is 0, it's a different case that you should understand. So let me write here, if y is x power 0, x power 0 is 1, so derivative of that is 0. So that is something which you should know. Dy by dx of the 1, which is a constant, is 0. But if you have y is x power half, then the corresponding dy by dx is half x power half minus 1, which is half x power minus half. So this is applicable for fractions also, if n could be a fraction also. So please keep in mind that this rule that we learned, that y is equal to x power n, where dy by dx is n x power n minus 1. This is applicable for n integers and n fraction, and this is some rule that we should learn. The next rule you would want to know is what happens if you are adding two functions. You would, for example, have, for example, two functions f and g. So you have some function f of x and some function g of x, and you have a sum of this. For example, you have your y is a sum of two functions. Let us say x cubed plus x square. So that is your y. Assume if your y is x cubed plus x square, then dy by dx is basically the derivative of f, which is df by dx, plus the derivative of this dg by dx. In other words, derivative of x cube, which is 3x square, according to the formula that we learned, n x power n minus 1, and derivative of x square is 2x power 2 minus 1, which is 1. So this is going to be the derivative of this. So you have derivative of f, which is df by dx, derivative of g, which is dg by dx, and the sum of this would give you the derivative of this function. So that is the next rule that I want to specify here. If you have two functions f and g, the derivative of a sum, that is derivative of f plus g, is derivative of the function f plus the derivative of this function g. Actually, if you think about this, you can extend this to many interesting simple things. For example, if you have 2x. So let us say the function that you have is y is equal to 2x. This y is equal to 2x can be written as x plus x. Now if you want to calculate dy by dx, you want to calculate the derivative of 2x. You know that the slope of 2x is 2, which is a straight line, and we know about the slope is 2. But we can also see from this rule that we applied, which is derivative of x, which is a line with slope 1, plus the derivative of this, which is 1. So this y is equal to a, this x and x are two functions which have slope 1 and 1. So therefore, this will have a slope 2. So the dy by dx for 2x is 2, something that we know from what we learned. So if you have a function y is equal to x, it can be written as sum of x plus x, and the derivatives we can calculate, we can apply this rule and see for yourself that dy by dx is indeed 2. So this rule is simple, and that it is a fundamental nature, that it will be useful to think about what we learned also. Do think about what we learned. See if this rule is applicable wherever we have learned things, right? So do think about it, and then that's what this rule is. dy by dx of f plus g is df by dx plus dg by dx. Now, once you have this, obviously the next question would be, if you have a product, right? If you have two functions, let us say f times g, if you have product of two functions. So let us try about that later. So let us think about it now. So if you have your y is product of two functions, f times g. What is dy by dx? So it turns out that the way to calculate dy by dx is keep f constant and find the derivative of g, plus keep g constant, find the derivative of f. So f dg by dx plus g df by dx. So this is the derivative of y. So if you have product of two functions, this would be the answer. You could think of any two functions like we did. You could think of x cube times x square, which is x power 5 we know, but let us do it as separate two functions. This would be keep x cube as it is, and the product of x square, derivative of x square is 2x, plus keep x square as it is, and derivative of it is 3x square. So this is something that this way you can write, and you will get this answer, the appropriate answer one can write down. So this we can also think about this in much simpler way. So let us take x square itself. So let us take the example of y is equal to x square. So you have y is equal to x square, which can be written as x times x. So then you want to calculate dy by dx. So which is keep the x constant and find the derivative of this x, plus keep this x constant and find the derivative of this other x. So what is this? This is x. The dx by dx, derivative of x is 1, and here also derivative of x is 1. So the answer is 2x. So derivative of x square is 2x that we know. So this is another way of finding the same thing. That is, you can use the product rule to find the derivative of x square or any complicated function that we have. So once we understood these two simple rules, f plus g and f times g, we can essentially find out derivatives of any function that we want essentially, and we will see some more complex, more complicated functions that we'll have learnt. We'll try and we'll go and examine some other functions and what are the derivatives of this. So the rule here is, this is the derivative of product, d by dx of f times g is f times dg by dx plus g times df by dx. So this is the product rule of finding derivatives. So you have to just know these two rules, the sum rule and this product rule, and we can learn many other things here. Now when we have this product rule, imagine that if f is a constant, what does it mean? So let us say if you have a constant here, which is, let us say you have y is equal to 3x power 7. So here what we have is, this is your f if you wish, this is your g if you wish, right? So according to that rule, f times dg by dx, so you have dy by dx is 3 times derivative of this, which is 7 x power 6. So x power 7's derivative is 7x power 6 plus g, which is x power 7, times derivative of 3, which is 0. 3 is a constant, so derivative of f, which is derivative of 3, is a 0. So this is nothing but 3 times derivative of x power 7. So 3 times 7x power 6, which is nothing but the derivative of x power 7. So whenever you have a f is a constant, the second part of it will always be 0. So only you have to do, keep the constant as it is and find the derivative of this. So if f is a constant, the answer will be f times dg by dx. If f is a constant, dy by dx will be just f times dg by dx. So keep this in mind, that if f is a constant, you would come across many situations where this f is a constant, or one of it is a constant, and you can calculate the derivatives using the same rule, but just by applying some common sense. Okay, knowing this is enough to know a derivative of pretty much anything. So let us now go and learn the derivative of some other function, let us say e power x. So we have learned what e power x is. So e power x, we said that e power x can be written as infinite series 1 plus x square by 2 factorial plus x cube divided by 3 factorial plus dot dot dot. So what is 3 factorial? 3 factorial means 1 times 2 times 3. 2 factorial means 1 times 2 times 1 times 2. So n factorial in general is 1 times 2 times 3 times up to n. So that is n factorial. If you don't know what this factorial means, do go and look some math books or search for in Google for this, understanding what this factorial is. Now we are interested in finding out derivative of e power x. What is the derivative of e power x? So we know that e power x is sum of many terms. So now derivative of a sum is individual derivative of each of this and the sum of it. So if I can find the derivative of 1 plus derivative of x plus derivative of x square by 2 factorial plus derivative of x cube by 3 factorial plus dot 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 is your derivative of this whole function. So what is derivative of 1? So derivative of 1 is 0. So derivative of 1 is 0. So let me write derivative of 1, which is the derivative of 1 is 0. Now what is derivative of x? So plus. So you have the derivative of x. Derivative of x is 1. So derivative of x is 1. Now what is derivative of x square divided by 2 factorial? So 1 by 2 factorial is a constant. It's just a number. 2 factorial is 2. So 1 by 2 factorial is a constant. So let me write plus 1 by 2 factorial is a constant as such. So I wrote here 1 divided by 2 factorial I kept as it is. And the derivative of x square is 2x. So this is the derivative of this term. Now plus derivative of this term is 1 by 3 factorial is a constant, so I kept as it is. And derivative of x cube is 3x square plus dot dot dot. So there will be an x power 4, it will have corresponding some term here and all that. Now if I rewrite this, what will I get? 1 plus 2x divided by 2 factorial. 2 factorial means 1 times 2. So this is 2. 2 divided by 2 is 1. So this is just x. So if I simplify this, 2 divided by 2 factorial is 1. Therefore this whole term is just x. Plus 3 divided by 3 factorial. 3 divided by 3 factorial. 3 factorial is 1 times 2 times 3. So 3 divided by 3 factorial is 2. So this is x square divided by 2 plus dot dot dot. So if you look at here and compare these terms with this original term, here it is 1, it is 1. X square by 2 factorial, here is also x square by 2 factorial. Actually there will be a factorial here, which is 2 factorial is 2 itself, plus dot dot dot. If I do more and more term, what I will end up finding is that derivative of e power x is e power x itself. So e power x is a very interesting function where its derivative is the function itself. So this is something interesting about e power x. Why? Many of you would wondering why are we so particular about e power x? We could have used 2 power x or 3 power x or 4 power x. We could use any exponential functions. Why are we so much interested in e power x? E power x has many interesting properties, and one of the interesting properties is that the derivative of e power x is e power x itself. So this is something that we would want to understand. So I urge you to do this derivative of all these terms. So take e power x as 1 plus x square divided by 2 plus x cube divided by 3 factorial, which is 6, x power 4 divided by 4 factorial, which is 24, x power 5 divided by 5 factorial, which is 120. So plus dot dot dot. So I urge you to take as many terms as possible. Do take more terms, x power 6, x power 7 and so on and so forth. Then calculate the derivative of each of this term. So whatever this denominator is can be kept as a constant, and you find the derivative of the numerator, and essentially you will find that d by dx of e power x is e power x itself. So this is an interesting property of e power x, that the derivative of e power x is e power x itself. So this is something that all of you should learn. Now we could think of e power minus x, right? So let us think of this e power minus x. So 1 e power minus x is 1 minus x plus x square by 2 minus x cube by 6 plus x power 4 by 24 minus x power 5 by 120 and so on and so forth. So just let us try this once more. Find the derivative of e power minus x. Let's try this ourselves to find the derivative of e power minus x and see what we would get. So let us quickly try this. So e power minus x is 1 minus x plus x square by 2 plus, minus, it's a minus sign here, minus x cube by 3 factorial plus x power 4 by 4 factorial plus dot dot dot. Let me rewrite that here. I didn't write it very neatly. Let me rewrite it here. E power x is 1 minus x plus x square by 2 factorial minus x cube divided by 3 factorial plus x power 4 divided by 4 factorial plus dot dot dot. This is e power minus x. Now, if I want to find the derivative of e power minus x, derivative of 1 is 0, derivative of minus x is minus 1, derivative of x square is 2x, so it's 2x by, so I will keep 1 by 2 factorial as a constant, and you have 2x, and you have minus x cube. So basically you have minus 3x square divided by 3 factorial plus 4x cube divided by 4 factorial, and so on and so forth and so forth. So if I do this and compute this derivative and compute the next, simplify this. So if I simplify this, it is minus 1, 2 and 2 cancels, so plus x, 3 and 3 factorial is 2 factorial, so minus x square by 2 factorial plus x cube divided by 3 factorial plus dot dot dot. And if you look at it, if I compare this, here it was 1, here it is minus 1. Here it is minus x, here it is plus x. Here it is x square by 2 factorial, here it is minus x square by 2 factorial. Here is minus x cube by 3 factorial, here it is plus x cube by 3 factorial. So it turns out that this is exactly, if I multiply with this with a negative, if I multiply this e power minus x with a minus 1, if I take all these terms and multiply with a minus 1, I will get this. So it turns out that derivative of e power minus x is minus e power minus x. So I urge you to work this out properly. Do this, take a pen and paper and do this yourself. Only by doing this you will learn this. So by doing this you will figure out how this will be, how the answer will be. You will learn that the answer is indeed this. Similarly, you can do for any function. So I also urge you to do for sin x and cos x. So sin x, we can write sin x as x minus x cube by 6, x power 5 by 120 and so on. And you find the derivative of it, you will find cos x. Do cos x, you will find the derivative as minus sin x. So if you expand sin x and cos x, you will find its derivative as appropriately derivative of sin x as cos x and derivative of cos x as minus sin x. Do this, and in the next lecture we will discuss more about this. To summarize what we have learned so far, the most important things that we learned are 3 rules. One is derivative of x power n is n x power n minus 1. Derivative of sum, which is f plus g, is df by dx plus dg by dx. And derivative of product fg is f dg by dx plus g df by dx. With this, we will stop this lecture and continue in the next lecture. See you. Bye.